the increasing throughput. So I will be going through our technology for fast sustainable wireless and some techniques how our antenna technology helps you to increase your throughput and overcome some of the obstacles that you are dealing with, and how to deliver more throughput to your current users. So the challenge that we are facing now in these days is really increasing demand for throughput. And if you look at this, the number of users that are requiring broadband internet, we can see that really it's growing constantly year over year. And the other challenge, along with the number of users, is the demand for throughput per user. So it is also growing rapidly year over year. And we can see that in 2016, the average speed per user was over 6 megabits per second, with currently more than 3 billion of people requiring the connectivity. So it's really clear to see that that's the challenge. And also, while we did the survey in November last year, where we asked WISP about their biggest challenge, and as you can see, really the increased demand for throughput is one of the biggest issue for them or for WISPs. So that's the challenge, but really the real challenge here, when we are trying to deliver required speed, is a lack of the spectrum. So available frequencies that we are allowed to use, and the inefficiency of the spectrum due to noise and interferences really reduce the usable spectrum that we have. So to deal with a growing demand for throughput, the new standards that introduce higher theoretical speeds with a higher modulation rate are delivered from standardization organization, but all these new techniques requires even more spectrum. So basically the spectrum that we have right now is limited due to a high amount of RF interferences. And from the other side, the wireless vendors bring advanced technologies and complex solutions like GPS sync to help to utilize the channel more efficiency, TDMA, which is usually vendor dependent and fixed due to the specific vendor, active filtering, and others, which basically add only the cost and complexity to your system. And all of these techniques are used to address the growing demand for throughput, but none of these techniques are really sufficient because they are not dealing with the core of the problem. And the core of this issue is RF noise. So vendors today are not solving your problems at their roots, but they are trying to deal with the consequences. And that isn't really the right approach. So they should solve the problem at the core, not to use all of those complex techniques to work around what is really there. The inefficiency antenna technology that is just adding the noise floor rather than to reduce it. So if you look at the source of this interferences issue, it's really a poor solution that vendors are putting out. So some kind of a shielding technology, and this might help you with some issues, but it's really not helping you in the throughput issues. It's wrapping your RF signal, so it's making it more unbalanced, and therefore you are not able to maximize your throughput. So it's really a poor design of RF signal at the end. So these shieldings are not only for point to multipoint, but also for point-to-point links, and it's really gone as far as putting the shielding on even CPE's devices. And if we look into the issue from radio point of view, so manufacturers are adding just more and more complexity into these units. And in early days, all of these enclosures were plastic, so they were leaking the signal everywhere. As and as times go by, the GPSing was added to the radio, then the active filtering that just result in increasing the complexity and cost of the units. And all of this have been done to deal with the problem of antenna and inefficient spectrum usage rather than to try to solve the core of the problem. So solution from our company, so from RF Elements, is really simple. So we are dealing with the source of the problem. We do not we do this with antenna that reject noise, with antenna that without side lobes, and these antenna basically don't accept the noise, so they help you to operate better. And also they don't create more noise, which you will have to deal with later. And also our solution is on almost zero loss thanks to our twist port connector. So we are able to reduce the loss that is in a traditional system for outdoor wireless by removing the pigtails. So the first feature is the noise rejection. And if you look at a typical patch panel antenna, really these antennas have huge and very complex side lobes. So if you look at the side lobe size proportion, side lobes are really huge. And these side lobes are not only noise generators, but also a huge receptor of noise. So side lobes are really stronger than you would think. And they are really issue when you are trying to do the collocation or channel reuse, and not only on your tower, but also on neighboring towers. And then with our symmetrical horn antenna, the signal really purely goes only in the direction you want it to go, and there are no side lobes, so nothing but the main beam connectivity with very, very precise antenna pattern. And the same happens for point-to-point. So huge side lobes exist with high gain antenna as well as parabolic dish antennas, and the side lobes are usually even bigger than with the sector antenna, because the front gain of the point-to-point antenna is bigger compared to the sector antenna. And what is even worse, you have the same antenna on the both ends of the link. So this means that you would collect the huge amount of noise on both sides of the link. And if we go on our horn technology and using them in point-to-point, they are really highly directional point-to-point antenna with no side lobes and very precise beam. So the signal purely goes only in the direction you want it to go, and if the clients are outside the main lobe, signal drastically drops. So they are much more efficient in delivering the signal to the client, and also extremely efficient in rejecting the noise from outside the main lobe. And the second feature was zero loss. So typically you have 3 items in your configuration, which is a radio, antenna, and cables. So the signal travels through the coaxial cables from the radio to the antenna, and in these cables part of the signal is lost, and on average you can see from about 2 maybe to as high as a 3 dB loss just because of the cable. And that's not all. They don't cause only the loss, but there is also a very high failure rate due to this cable. So you need to have a proper configuration of the pigtails. It depends on who make it for you. Whenever you have right angle of the connector, the quality of the cable, then you need to be aware of water ingress. So really too many things that can go wrong. On the other side, our proprietary twist port waveguide connector has no cables and no coaxial components, so it uses the waveguide to transport the signal from the radio to the antenna, and really it's extremely easy to use and very durable. And it's not only eliminating the number one source of the loss, the pigtails, but also the number one source of failure, which are again the pigtails. But let's do some comparison between the traditional sector patch panel antenna and our horn antenna. So if you look at the traditional sector antenna for MIMO, you have a horizontal and vertical beam. And the overlay between the horizontal and vertical beam are usually not matched. So you have the coverage pattern mismatch, where towards the edge of the sector and in front of the sector, you don't have a sufficient overlap. You also have a noise that comes in through the huge side lobes that are on the back side of the antenna, and also as gets towards to the edge, you have areas with a low performance. So that's the area where gain starts to drop off. So when you look at the coverage area, you can see that the center of the coverage is kind of the sweet spot. That's the, the clients or CPs where probably get the best gain and best horizontal and vertical performance, and therefore you get a good signal and good speed there. But when you start going to the edge of the sector, the signal and the performance start to decrease. But with our horn antenna, you have perfectly overlap horizontal and vertical beam patterns, so you have nothing but the main beam connectivity with a constant gain and good signal. So it means that all of your clients are getting a good modulation rate, stable modulation rates, and much better performance. So if you look at the overall performance of the traditional sector, you can get some mixed of the speed depending on where your clients are. So the average speed that you are able to deliver with the traditional sector is, greatly reduced. But with a horn antenna, everybody have a good chain-to-chain performance and good horizontal and vertical gain, and therefore the modulation rates are much more stable, and you are able to deliver higher speeds as you have with the traditional sector, and much better signal across the whole sector and all clients. And it does not, change based on your client location within the beam. So let's have a look at the noise rejection as you have it deployed on the tower. So you have your AP on the tower and the clients out in the field. So with the traditional sector, you can get, average throughput, usually not the throughput that you want it to get, or the throughput that, that the radio is capable, because the radio is dealing with the noise, and as you get to the edge of the sector, the modulation rates basically drop down. But because the horn antenna has no side lobes and perfect horizontal and vertical beam performance, all of your clients are in a perfect signal area, and therefore the link throughput as well as overall throughput of the radio is maximized. So you are not seeing the decrease on the customers that are far away or customers on the edge of the sectors, and you are not dealing with the performance hits of receiving noise. So the overall performance of the horn antenna definitely gives you much better average speed across all of your clients, and therefore much better user experience. And if you look at the collocation issue that you have with the traditional sectors and how our symmetrical horns help you, so currently you deploy again the traditional sector to cover the clients that you currently have. So you have kind of the average speed, because of the noise issue and where the clients are located. Then when you add additional clients, your link performance significantly drops because radios are only capable to handle a certain number of clients, as we all know. But with the symmetrical horn, because we have a narrow beam width, you can deploy multiple APs with no collocation issues to cover the growing number of customers in your coverage area, and all of them receiving good speed across the board. So this is the great way of increasing the throughput by using the ability of horn antenna to collocate multiple APs in the same coverage area. So you don't need to overlap a whole beam of the antenna and pointing more traditional sector or 90-degree in 90-degree area, but you can rather split the sector into 330-degree areas and providing full speed to your customers. So here we have old versus new one. So as I mentioned, traditional sector antenna has a problem because of receiving the noise through the side lobes. You also have a performance issue because the modulation rate, the link rates, and the data rates in your coverage area vary, and you have a kind of a sweet spot in the center of the area, and at the edge of the coverage area, the speeds decrease. And also, the client density is increasing in your coverage area, and you don't have the ability with the traditional sector to go ahead and segment or split the sector into more narrow ones. but simply 2 or 3 symmetrical horns will easily outperform 2 or 3 traditional sector antenna trying to cover the same coverage area. And here I would like to talk about the channel availability, and this is usually the #1 topic when we are speaking about the horn antennas and efficiency of using horn antenna in specific areas. So the channel availability. So the typical feedback that we get is, I do not have enough free channel, but actually that's not right, because you do. So if you look again on how traditional sector antenna works, so you deploy your first AP at, for example, 5700 megahertz, sorry, and then you have other sectors covering the same client. So because your traditional sector has such a wide angle and huge side lobes, it actually hearings those other 2 sectors that you have in the area. But if you put your horn antenna up, what you saw before was the spectrum scan with no available channel, but now those channels are available. So essentially, when you look at on the available channel that you have on your tower site, the reason you think you don't have free channel is because you are looking through the eyes of your regular sector. But once you put on the horn antenna and you point it in the same direction, you will see that the channels that weren't available before are now available. So that's because traditional sector are hearing so much signal coming from a backside and also side of the coverage area through the side lobes and really wide radiation angle. So precise radiation angle of horn antenna filter that out. And the same thing happens with the noise floor. So noise floor is really a big thing. So you are always looking for the signal noise ratio and how much more signal you can get over the noise floor in order to successfully get highest modulation rate. So you are always looking maybe to 20 to 25 dB above the noise floor. So if you have your regular your regular coverage area, the noise might coming in from the towers that are further away, and because those towers are sending noise through the side lobes, so your noise floor will start to grow. But in the same way as with the collocation channel, with the channel availability, the noise floor issue also goes away, because a horn antenna does not have side lobes, and therefore the spectrum is way more usable than you think it is. So when you look at the spectrum through the horn antenna, it looks totally different, way more efficient, and it allows you to reuse channels that you were not able to use before. So before you say, I don't have a free channel, try to use a horn antenna, and then you will see exactly how many channels you have and what your spectrum could look like if all of your AP were on a horn antenna. And the really massive scalability is one thing that really is where we need to go. So you saw earlier on how the number of users are growing globally, and the demand for throughput per user is growing as well. So in order really to cash in to this growth, you really need massive scalability. So traditional sector antenna, or the sector antenna today, are using the technology with the huge side lobes and high gain, and it's absolutely not necessary or wrong way to approach the need for a massive scalability and increased throughput demand. So you need the spectrum to be clean, or at least to be able to cut through the spectrum. So horn antenna gives you the massive scalability. So if you look at 3 potential sites and you look at doing them with the traditional sector antennas, you have a medium, maybe some decent throughput as the noise comes in, and the overall throughput really goes down. But if you use a horn antenna technology, your throughput goes up. So we give you the ability of massive scalability to go ahead and segment those deployments up to multiple sectors, and therefore delivering way more overall throughput to all of your clients, and with a good noise rejection. So there is no antenna technology except the symmetrical horn antenna that will allow you to deploy the massive scalability that you really need to match the growing demand for throughput today. So our technology for fast, sustainable wireless is really quite simple, and that there is no need to use a 19 or 22 dBi sector to only go 1 or 2 miles. So we have also low gain antennas that are much better suited for those types of deployments, or for short range. And if you have a large number or high density of customer in specific area, stacking multiple traditional sector takes up huge amount of space on their tower, increasing wind loads, and it's not able to even deliver the throughput that you need. But with the horn antenna, this problem is solved. So our twistport technology also allows you to utilize our whole ecosystem. So as you grow and you change technology from 802.11 and to potentially AC, or our twistport ecosystem allows you to incorporate these new radios without having to change the antenna. So really, it's somewhat vendor neutral, and all this stuff give you the massive scalability that you need for delivering the throughput that's demanded today. So the key message here is, by increasing throughput with horn antenna, there is no need for GPS synchronization. You can use any radio that you want. You don't need to use a wide channel, so no need to go to 40 or 80 megahertz wide channels. You can use much narrower channel. In fact, the horn antennas are so effective delivering you quality signal and maximizing your throughput that in many cases you can deliver more throughput to your customers on a 20 megahertz channel on the horn than you were with the 40 megahertz channel on the traditional sector. And it's because the traditional sectors, again, are so inefficient at propagating quality signal to your coverage area, that the 20 megahertz channel will deliver in most cases more throughput than the 40 megahertz channel on the traditional sector. And again, there is no extra cost, right? So horn antennas are extremely cost efficient. So no need to buy shielding to put on these sectors to try to help you with the noise issue. There's no need to spend tons of money on some really complex radio system that have active filtering or GPS. So you can get away with running a lower end radios that are on the market and still deliver really good throughput to your end user without having to migrate to the newer platform. So the cost efficiency is really good with a horn antenna when you compare it to the traditional land sector. So we have 7 different types of or different models of horn antenna with a twistport connector. So the narrow run is 30 degree, and then with 10 degree step it goes up to 90 degree. This is really just a brief summary of the models. If you want to know more parameters or more details about specific model, you can go to our web page and check the data sheet. There is plenty of information about this antenna. That was the part of the webinar. Here I would like to invite you to join our community, which is rfelab.com. When you register there, it's for free. You will have an access to really interesting information from other customers as well from our side. You can check out how our customers are using the antenna, what kind of issues they are dealing with, and what are the questions that they have, and so on. So really a lot of useful information on rfelab.com, and also a lot of our employees, I mean people from RF Elements is there. So if you have any question, we will try to answer it there as soon as possible. Also, we have our well, YouTube channel, and as we visit a lot of events, we are trying to ask or interview our customers that we meet there about their situation. So what was the problem, why they decide to go with RF Elements antenna, how are they satisfied or not, and what's the story. So a lot of interesting interviews on our YouTube channel. So if you have time, it's really short interview, so go there and check it. It's very interesting to hear it all around the world. So we are not just on the RFE Lab. We are just on RFE Lab, but or YouTube. We are on all of the social medias which are listed here. So if you want to get the latest news from our site, just follow us or like us, or check these social medias, and you will be up to date. So that was all from my side from the webinar part. We don't have any questions, so I believe that all of you, or it's clear for all of you that and you understand that really with the horn antenna technology, the increasing throughput that is really required and everybody is asking for is very simple and very easy to deploy, and you don't need to spend tons of money to some kind of very complex method and methodologies to try to cover such a demand. So really the simple way is to use the horn antenna. So that's all. Again, I would like to thank you, our distributor, which is Avantis in Norway. They are really nice guys. So they organized this webinar, of course, but they also have all of our products. So if you are willing to try it, so I'm sure that when you contact the guys in Avantis, they will help you immediately or very quick. And I think that if you use it, as I showed you, you will be very satisfied with the performance. So that's all from my side. Again, thank you for attending, and have a great day. Bye.